This is SpaceTime Series 25, Episode 90. Coming up on SpaceTime, the red supergiant Betelgeuse blows its top. Could Earth's continents have come from outer space? And bound for the moon, NASA's Artemis 1 rocket rolls out onto the launch pad. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have now concluded that the sudden dimming of the semi-regular variable red supergiant star Betelgeuse back in 2019 and 2020 was caused by blowing away a massive chunk of its stellar surface. You may recall back then the event sent alarm bells ringing around the astronomical community. Suddenly, the ninth brightest star in the night sky had dimmed down to the 20th. And speculation abounded whether Betelgeuse was about to go supernova. Initially, astronomers were unable to explain the strange event. Betelgeuse regularly pulsates, but not to this extent. This was completely unprecedented. Eventually, astronomers discovered the dimming was caused by a massive cloud of dust blocking out much of the star's light. But where was the dust from? And if it was from Betelgeuse, how could there be so much? Now, analysing data from NASA's Hubble Space Telescope together with several other observatories, astronomers have concluded that Betelgeuse quite literally blew its top off in 2019, losing a substantial part of its visible surface and producing what they're now calling a gigantic surface mass ejection. This is something that's never been seen before. Of course, the Sun routinely blows off parts of its tenuous outer atmosphere, the corona, in events known as coronal mass ejections. But that's quite different to the Betelgeuse surface mass ejection event, which blasted off some 400 billion times as much mass as a typical coronal mass ejection. The monster star is still only slowly recovering from this catastrophic upheaval. The study's lead author, Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics, says Betelgeuse is continuing to do some very unusual things, with its interior sort of bouncing around. These new observations are yielding fresh clues as to how red supergiants lose mass late in their lives, as their nuclear fusion furnaces start to burn out in the countdown before they explode as core collapse supernovae. The amount of mass loss significantly affects their fate. However, Betelgeuse's surprisingly petulant behaviour isn't evidence that it's about to blow up anytime soon. So the mass loss event isn't necessarily a signal of an imminent explosion. Dupree is now pulling all the data pieces she can gather together, looking at what she can from before, during and after the eruption, placing it all into a coherent story of this never-before-seen titanic convulsion of an aging star. The data includes new spectroscopic and imaging observations from NASA's Hubble Space Telescope, the Strela Robotic Observatory, the Fred L. Whipple Observatory's TRESS spectrograph, and NASA's Stereo A spacecraft. Dupree says Hubble's data was pivotal in helping to sort out the mystery. She says astronomers have never before seen such a huge mass ejection event from the surface of a star, and they don't really understand what's going on. It's all a totally new phenomenon that's being observed for the first time. But Hubble is allowing astronomers to observe Betelgeuse's surface details and its evolution in real time. It's thought the titanic outburst in 2019 could have been caused by a convective plume some 2 million kilometres across, which bubbled up from deep inside the star. It produced shocks and pulsations that blasted off a chunk of the photosphere, leaving the star with a large cool surface area under the dust cloud that was produced by the cooling pieces of photosphere. Betelgeuse is now struggling to recover from this injury. Weighing roughly several times as much as the Earth's moon, this fractured piece of photosphere sped off into space and cooled to form a massive dust cloud, big enough to block light from the star as seen by Earth observers. The dimming, which began in late 2019 and lasted for several months, was easily noticeable by backyard observers watching the star change brightness. Even more spectacular, the red supergiant's 400-day pulsation rate, one of its key characteristics, is now gone. Possibly only temporarily, but, well, who knows? This is all new territory. For almost 200 years, astronomers have been measuring the rhythm of this pulsation, as evident in changes in Betelgeuse's brightness, variations, and surface motions. Dupree thinks the star's interior convection cells, which normally drive this regular pulsation event, may be sloshing around inside the star like an unbalanced washing machine tub. The TRES and Hubble spectra suggest that the outer layers of the star may now be back to normal, but the surface is still bouncing around like jelly as the photosphere rebuilds itself. Though the Sun has coronal mass ejections that blow off small pieces of the outer atmosphere, astronomers have simply never witnessed anything this large before, and so they're fairly convinced that surface mass ejections and coronal mass ejections may be very different events. Betelgeuse is the brightest star in the constellation of Orion, representing the scorpion sting on Orion's shoulder. Located somewhere between 530 and 643 light-years away, depending on whose measurements you prefer, it's one of the largest and most luminous stars visible with the unaided eye from Earth. Commonly called Betelgeuse, don't say it 3 times, its original name before centuries of tortured mispronunciations started out as Ibdal Yaza, meaning the right hand of the big man in Arabic, the big man being Orion the Hunter. Betelgeuse began its life around 10 million years ago as a spectral type Ob blue star. Calculations of Betelgeuse's mass range from slightly under 10 to a little bit over 20 times that of the Sun, with around 100,000 times the Sun's brightness and around 1,100 times its diameter. In fact, Betelgeuse is so big, were it placed where the Sun is at the center of our solar system, its visible surface would extend out beyond the orbit of Jupiter, engulfing the orbits of Mercury, Venus, Earth, Mars, and the main asteroid belt. Red supergiants are the largest stars in the universe in terms of their volume, although they're not necessarily the most massive or luminous. After spending millions of years fusing hydrogen into helium in their cores, a star's core hydrogen supply eventually runs out, and the balancing act between the nuclear fusion process pushing out and gravity pushing inwards stops, and gravity wins. Now, the huge mass of the star crushing down onto its core under its own gravity causes a dramatic increase in core pressure and consequently temperature. Eventually, things get hot enough that it triggers what's called a helium flash, which causes the helium in the core to start fusing into carbon and oxygen. Now, at the same time, the contraction of the core means the hydrogen-rich region around the stellar core has moved down into the area where temperatures and pressures are hot enough for hydrogen fusion into helium to commence, creating a shell of burning hydrogen around the core. Meanwhile, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand hundreds of times beyond its previous radius. As the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder, and hence the star has become a red giant. Stars like our Sun will eventually lose their outer envelopes, which continue expanding outwards as planetary nebulae. This ultimately exposes the star's white-hot stellar core as a white dwarf. However, stars like Betelgeuse, with masses more than 8 times that of our Sun, experience a very different fate. Unlike our Sun, because they have so much more mass, their fusion cycle doesn't end with helium fusing into carbon and oxygen. They have enough mass to fuse the carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while shell burning around the core also fuses progressively heavier and heavier elements. So we have carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. But no matter how big a star is, it can't fuse iron into heavier elements. And at this point, the star reaches the end of the line. Once again, that balancing act between nuclear pressure pushing outwards and gravity pushing inwards ceases, and gravity wins, and the star quickly collapses in on itself. Now, if they're between, say, 8 and 20 times the mass of our Sun, they'll produce a spectacular event called a core collapse supernova, and they'll end up as a neutron star. However, if they're more than 20 times the mass of the Sun, chances are the collapse will continue beyond the neutron star stage and they'll form a stellar mass black hole, a point of singularity of infinite density in zero volume, a place where the laws of physics as science understands them no longer apply. As for Betelgeuse, well, it's expected to explode as a core collapse supernova sometime soon, which in astronomical terms could mean tomorrow or it could mean 1,000,000 years from now. Whenever it happens, we'll notice, assuming the human race is still around. It'll temporarily outshine all the other stars in the galaxy, and it will be clearly visible in the day's sky from Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho's star. That was back in 1572, and that was before the invention of the telescope. This is space-time. Still to come, could Earth's continents have come from outer space? And NASA's DAVINCI mission to explore the atmosphere of Venus. All that and more still to come on Space-Time. Okay, let's take a break from our show for a word from our sponsor, NordVPN. VPNs, or virtual private networks, have become an increasingly important tool in the modern world. Whether you're a business traveller trying to keep your work data secure, or someone who just wants to keep their browsing habits private, a VPN can be a lifesaver. And if you're not using one, you're putting yourself at risk for exploitation. While there are many different VPN providers available, we use and recommend NordVPN. They offer a high quality of service and strong security features, and there's a 30-day money-back guarantee if you're not completely satisfied. And there are a number of different plans with great savings for those who sign up for longer terms. So, if you're not using a VPN yet, now's the time to start. And we've got some great deals for you as a Space-Time listener. Just go to nordvpn.com/Stuart Gary and click on the Get the Deal button. Now, I'm using the complete security package, which comes with a huge 69% discount for 2 years, plus access to NordPass, the cross-platform password manager. There's malware protection and a terabyte of secure cloud storage, plus more. And for the budget conscious, there are 2 more deals which will suit you. So come check it out for yourself. You won't regret it. That URL again is nordvpn.com/Stuart Gary and click on the Get the Deal button. nordvpn.com/Stuart Gary or use the code Stuart Gary at the checkout. And of course, you'll find the URL details in the show notes and on our website. And now, it's back to our show.
This is Space-Time with Stuart Gary.
A new study suggests that Earth's continents could have been formed by material delivered in giant meteor impacts. The findings, reported in the journal Nature, are based on detailed studies examining the composition of oxygen isotopes in zircon crystals found in the Western Australian Pilbara region, which contains some of planet Earth's oldest continental crusts. The study's lead author, Tim Johnson from Curtin University, says the Earth suffered a high number of asteroid and meteor impacts during the first billion years of the planet's 4.6 billion year history. Johnson says the idea that continents originally formed at sites of giant meteoroid impacts has been around for decades, but until now there's been little solid evidence to support the hypothesis. By examining tiny crystals in the mineral zircon in rocks from the Pilbara Craton, which represent Earth's best preserved remnant of ancient crust, the authors found evidence for these giant meteorite impacts. Johnson says studying the composition of oxygen isotopes in these zircon crystals revealed a top-down process, starting with the melting of the rocks near the surface and progressing deeper, consistent with the geological effect of a giant meteoroid impact. He says the research provides the first solid evidence that the processes which ultimately formed the continents began with giant meteorite impacts similar to those responsible for the extinction of the dinosaurs, but which occurred billions of years earlier. Johnson says understanding the formation and ongoing evolution of Earth's continents was crucial, given that these land masses host the majority of Earth's biomass, all humans, and almost all of the planet's most important mineral deposits. These mineral deposits are the end result of a process known as crustal differentiation, which began with the formation of the earliest land masses, of which the Pilbara Craton is one example. Data related to other areas of ancient continental crust on the Earth appear to show patterns similar to those recognised in Western Australia. Johnson says he wants to test his findings on these ancient rocks to see if the model holds out.
So we know continents, continental crust, which is mainly made up of granites, these pale-coloured rocks that many of us have got on our kitchen surfaces, work surfaces. We know they've been around for 4 billion years or so, and some of that evidence is right here in WA. However, exactly how the continents came to be, how they first formed, is very poorly understood. Now, most people, I would wager, would say that there are competing models for how the continents first formed, but most people would favour internal processes. So, as you and your listeners will know, the Earth is very hot in its middle, and like any other bodies that have accreted, they started with lots of heat, and that heat has got to go somewhere, so it makes its way out from the core to the surface. And that's what we think is driving plate tectonics, which is operating today, and pretty much any active process that we can see operating on Earth, earthquakes and volcanoes and stuff. Now, some people would believe that the first continents formed by subduction, so much in the same way as they do today, where you have these rigid plates of oceanic crust that are in places diving underneath one another. As they get very deep, they get hot and they melt, and then they produce these granites, the continental crust. The other sort of end member internal model would be so-called mantle plumes, where you've got these blobs of heat that come from the core mantle boundary. The mantle is the layer in between the core and the crust on which we live. So the mantle plume is a bit like a lava lamp, if you're old enough like me to remember lava lamps, where you're getting these blobs of heat making their way to the surface. And when they get close to the surface, they cause massive amounts of melting and the production of a so-called oceanic plateau. So the sort of thing that we know is present beneath Hawaii and Iceland and other things like that. However, it's always seemed pretty plausible to me that we could be looking at an external origin for the continents. And people have been proposing this since at least the 1960s. That's the first paper that I could find. But I'm sure the idea has been around longer than that. But it's not really been taken up by the scientific community because of the lack of any concrete evidence. And I think in this research we found some evidence that might suggest that this giant impact theory is actually right.
So this is different from material floating on the surface, which is sort of what we think of when we think of granitic material, the continental crust.
No, it absolutely is. But to actually make continental crust is a bit more involved. You need a two-stage process. So we know that the primitive sodium-rich granites that we find absolutely everywhere around the planet in the really ancient rocks, we know that they were formed by partial melting of basaltic rocks, but basaltic rocks that have been hydrated. So again, basalts are these dark volcanic rocks that come out of places like Hawaii and Iceland and other places as well. And providing you can add water to those things, you melt them to make these granites. And the granites are much less dense, and as you say, they float. But the question is, how do you make those really big blobs of basaltic volcanic rocks that can then evolve into become the granitic continental crust? And that's really what we are looking at, or we think we found evidence, this very first massive input of energy that gets everything kick-started.
And this is where zircons come in. They're so important, aren't they, to studying really ancient geology?
Absolutely they are. So zircon is a beautiful mineral. It occurs in many of these granites that make up the continental crust. They're very small, the grains. They're about the width of a human hair or so, but they're incredibly robust, physically and chemically robust. So the earliest material we know about on Earth are the so-called Jack Hills zircons, and they are getting close to 4.4 billion years old. So that's an awful long time for a mineral to hang around. So they are a robust record, or our only record of really what was going on in the early Earth. Now, the great thing about zircon, one of the great things, is that when it grows, it incorporates lots of uranium into its structure. And as we all know, uranium is a very heavy element. It's unstable, so it decays to various isotopes of lead. Now, with instrumentation we've got at Curtin, we can fire various beams at these tiny zircon grains, and we can measure those isotopes, and we can get a really quite precise age on those grains.
That's because the uranium is decaying into lead at a set rate.
That's right, yes. So there's actually two decay schemes where uranium decays to two different isotopes of lead. So two different isotopes of uranium decay to two different isotopes of lead, which gives us a check on our sums, basically. And if both of these things give the same age, both of these decay schemes give the same age, you can be pretty confident that your age is right and not some artifact. So if you're analysing lots of zircon grains, as we did, you've got a beautiful timeline of the processes that they record. Now, another thing that zircon and most other minerals contains is lots of oxygen. And we can measure two of the isotopes of oxygen, oxygen 18 and oxygen 16. Oxygen 16 is the common form of oxygen. And without getting into too much detail, that isotopic ratio tells us something about the environment in which those zircons originally crystallized. Now, in the Pilbara, there is the very, very oldest zircon grains we've got, which is the earliest record of what could have formed the Pilbara in the first place. They have about a third of the zircons have what we say is isotopically light compositions. And the only way of forming them, or at least the only way we think, or the most plausible way of forming them, is that they represent, to get these isotopically light compositions, you have to be melting something close to the surface. So within the uppermost few kilometres of the Earth. Now, anybody walking around on the Earth now and then would notice that it's not particularly hot. So to actually melt the surface, to cause this extensive surface melting, and then the pattern becomes successively deeper thereafter, is entirely consistent with this giant impact theory. So the first thing that's happening is you're smashing an asteroid into the surface of the Earth, so you're causing massive amounts of melting at the surface, and then as the whole system evolves, it becomes deeper and deeper. And that's entirely what the pattern of the Pilbara data is showing, and tantalizingly, it looks like that similar pattern you can see elsewhere. So it's this top-down pattern where you're starting from shallow to deep, which really gives us some confidence that the giant impact theory might be right. Because the main alternative, which is the mantle plume model, would start from very deep within the Earth and get progressively shallower. So it's the opposite of the trend we actually see in the data.
And this giant impact model, it matches up with things like the late heavy bombardment.
It does, yeah. So when you look at the Pilbara craton in detail, as other people have done, you can find these layers that we call spherular layers. So they are high energy impact deposits, and we can date those deposits as well. And for the Pilbara, we would argue that we had this giant impact at around 3.5 or 3.55 that eventually went on to become the Pilbara. But we can also see in the data these departures to isotopically light zircon, and they coincide beautifully with the age of these spherular beds. So we've got a direct link between the data and what it might mean.
Does that also help explain why the Pilbara is so iron rich?
That's another interesting aspect, yes. So not all, but in most of the samples that we're finding these really light isotopic compositions, the rocks in which they occur are very iron rich, as you say. And exactly why that is unknown, but we would argue that it's exactly what you would predict if you were crystallizing a terrestrial magma ocean. So again, as your viewers will be more expert than I, and many of them, the Earth is thought to have collided with a Mars-sized object here to form the Moon 4.5 billion years ago. So the Moon would have formed from that entirely molten mass, and the Earth would also have been completely molten to some depth. Whether it's right the way to the core, who knows, but a significant amount of the Earth would have been entirely molten. And then if you slowly cool that, it crystallizes from the inside out. So it's basically a basaltic composition, and you start crystallizing things like olivine and autopyroxene, and then the residual melts. What's left over as it cools gets successively richer in iron. So that's a nice little bit of a side story, really, that we might be impacting the results of the crystallization of the terrestrial magma ocean that would form when the Moon did.
So the key now, I guess, is looking for...
Well, the next stage, what we'd really like to do, so we've written some proposals to go and look at ancient rocks from elsewhere on the planet. So Pilbara is the most pristine example of this really ancient continental crust we have. But you can find fragments of it absolutely everywhere in Canada and Greenland and Europe and South America and wherever.
And South Africa too, yeah.
Precisely, South Africa, Barberton, beautiful place. So what we would like to do is go and recollect some of those samples and apply the same filters to the analyses that we've done for the Pilbara data to see if, as the data seems to hint at elsewhere, there is evidence of this giant impact model elsewhere. And perhaps, who knows, the giant impact model might be applicable to all continents.
That's Associate Professor Tim Johnson from the School of Earth and Planetary Sciences at Curtin University. And this is SpaceTime. Still to come, NASA releases details of its new DAVINCI mission to Venus, and bound for the moon, NASA's massive Artemis 1 rocket rolls out onto the launch pad in preparation for its maiden flight. All that and more still to come on SpaceTime. NASA has released details of its proposed new DAVINCI mission to the planet Venus. Slated for flight on a United Launch Alliance Vulcan rocket in June 2029, the Deep Atmosphere Venus Investigation of Noble Gases Chemistry and Imaging, or DAVINCI mission, will be the first to study Venus using both spacecraft flybys and a descent probe. A NASA report in the Planetary Science Journal describes how the DAVINCI descent probe will slowly drop through the layered Venusian atmosphere in mid-2031, recording changes in atmospheric chemical composition and environmental conditions all the way down to the planet's surface. It will also provide the first descent imaging of the mountainous highlands of Venus, while mapping their rock composition and surface topography at scales simply not possible from orbit. The mission will measure undiscovered trace gases in the deepest atmosphere, including key ratios of hydrogen isotopes, components of water that will help reveal the history of water either as liquid water oceans or as steam within the early atmosphere. The mission's flyby probe, called the Carrier Relay and Imaging Spacecraft, or CRIS, has two onboard instruments that will study the planet's clouds and map its highland regions during flybys. DAVINCI will paint a picture of the layered Venusian atmosphere and how it interacts with the surface of the mountains of Alpha Reggio, which is as big as the state of New South Wales, around twice the size of the state of Texas. DAVINCI's principal investigator Jim Garvin from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says these measurements will allow scientists to evaluate historical aspects of the atmosphere, as well as detect special rock types at the surface such as granites, while also looking for telltale landscape features that could show evidence of erosion or other formational processes. DAVINCI will make use of 3 Venusian gravity assists, which will save fuel by using the planet's gravity to change speed and direction. The first 2 gravity assists will set CRIS up for a Venus flyby, performing remote sensing in the ultraviolet near-infrared. The third Venus gravity assist will set the spacecraft up to release the probe for entry, descent, science, and touchdown, plus any follow-up transmissions to Earth. Scientists estimate the first flyby of Venus will be about 6.5 months after launch, and it will take 2 Earth years to get the probe into position for entry into the atmosphere over Alpha Reggio under ideal lighting conditions, with the goal of measuring the landscapes of Venus at scales ranging from hundreds of meters down to less than 1 meter. Such scales will enable lander-type geologic studies of the mountains of Venus without actually requiring a landing. Once the CRIS system is about 2 days away from Venus, the probe flight system will be released, along with a 2-meter-wide titanium probe safely encased inside. The probe will begin to interact with the Venusian upper atmosphere at an altitude of around 120 kilometers above the surface. But it won't commence its science observations until after jettisoning its heat shield. That'll be at about 67 kilometers above the surface. With the heat shield removed, the probe will then begin ingesting atmospheric gas samples, providing detailed chemistry measurements of the sort that have been made on Mars with the Curiosity rover. During its slow hour-long descent down to the surface, the probe will also acquire hundreds of images as soon as it emerges from under the clouds, That should be at around 30,000 metres, 30 kilometres above the local surface. If all goes according to plan and the winds don't blow it off course, the probe will touch down somewhere in the Alfa Reggio Mountains. Now, if it survives the touchdown, and it will be hitting the ground at around 12 metres per second, there could be up to around 18 minutes of bonus operations and measurements of the Venusian surface. Of course, the problem is, no spacecraft have survived long in the Venusian atmosphere, or for that matter on the surface. The Russians have tried, sending back tantalizing images of the surface and readings lasting a few minutes before systems all failed. The problem is, while Earth and Venus are considered sister planets, both roughly the same size, the same mass, made out of the same material and formed in the same part of the solar system under similar conditions, Venus and Earth have turned out very differently. Temperatures on the Venusian surface are hot enough to melt lead, more than 460 degrees Celsius. Atmospheric pressure at the surface is 100 times greater than at sea level on Earth, and it's an atmosphere heavily dominated by carbon dioxide. When it does rain on Venus, it rains sulfuric acid, and the snow on the mountain tops is metallic. So anything landing on Venus will get crushed, cooked, broiled, boiled, and burnt. This report from NASA TV.
Launching in 2029, the DAVINCI mission, named after Leonardo da Vinci, is designed to address fundamental questions about the origin, evolution, and composition of Venus. During 2 gravity-assist flybys, Da Vinci will study the cloud tops in ultraviolet light, tracking cloud patterns as they change with time and analyzing signatures of mysterious chemicals that absorb ultraviolet light. Both flybys will also examine heat emanating from the Venus surface on the planet's night side. We will look for geological clues of this planet's mysterious past to paint a global picture of surface composition and the evolution of the planet's ancient highlands. 7 months after our second flyby, Da Vinci will release its atmospheric descent probe. The spacecraft will watch its probe enter Venus's atmosphere over the course of 2 days. The probe will take about an hour to fall through the atmosphere, taking measurements and snapping images down to the surface. These measurements include profiles of composition, winds, temperature, pressure, and acceleration. Key gases will be measured to help us understand how Venus formed and evolved. Some of these measurements may reveal chemical signatures of ancient water. With our suite of measurements, Da Vinci will provide new insights into Venus's atmosphere's complex composition, structure, and chemistry. As the probe nears the surface, its descent camera will capture breathtaking bird's-eye views of the mysterious terrain known as the Alfa Reggio Tessera, possibly revealing evidence in the rocks that water once flowed across the Venusian surface. These up-close images of the surface will provide new insights into geologic processes and will help us to understand what it might be like to stand on the Venus surface. An oxygen-sensing student collaboration experiment will shed light on the role of this gas in the Venus atmosphere. The discoveries that emerge from this diverse data set will tell us whether Venus was truly habitable, and the story we reveal at Venus will reach even beyond the solar system to analog exoplanets that will be observed with the James Webb Space Telescope.
This is SpaceTime. Still to come, NASA's Artemis 1 moon mission rolls out onto the launch pad, and later in the science report, a new effort using cloning to try and bring the Tasmanian tiger or thylacine back from extinction. All that and more still to come on SpaceTime. NASA's Artemis 1 SLS Moon rocket is back at Space Launch Complex 39B at the Kennedy Space Center in Florida as preparations continue for its historic maiden flight later this month. Crowds began building up around Cape Canaveral as the massive 98-metre tall rocket undertook its historic 7-kilometre 10-hour overnight rollout from the massive vehicle assembly building out to the launch pad, arriving at dawn. The first of 3 launch windows for a flight this year will be on August the 29th. The unmanned test flight, which will last some 42 days, will travel beyond the Moon, deploying a number of microsatellites and CubeSats along the way. Replacing the crew will be 3 mannequins loaded with sensors to measure radiation and vibrations. The mission's Orion capsule will then return to Earth, entering the atmosphere faster than any other human-rated spacecraft ever, eventually splashing down in the North Pacific Ocean. Now, if successful, it'll be followed by the Artemis 2 mission, slated for May 2024, and that will be the first manned flight carrying a crew of 4 around the Moon and back. That in turn will be followed in 2025 or possibly 2026 with the Artemis 3 mission, the first manned flight to the lunar surface since Apollo 17 back in 1972, more than half a century ago. Once in lunar orbit, the Artemis 3 Orion capsule will dock with a pre-positioned SpaceX Starship HLS lander. 2 of the Orion crew members will then transfer to the lander and travel down to the lunar surface, touching down near the South Pole for a week-long stay, undertaking science observations and collecting samples. Scientific equipment and supplies will be pre-positioned at the landing site. And NASA assures us this time humans will be back to the Moon to stay. An orbiting lunar space station, the Gateway, will be positioned in the second half of the decade, and eventually the experiences learnt by working on the Moon will be used for the first manned missions to Mars. And they'll take place sometime in the 2030s. This report from NASA TV.
Through Artemis, the twin sister of Apollo, we are returning to the Moon. Orion, the only human-rated spacecraft in the world capable of deep space travel. And now, the Space Launch System, NASA's most powerful rocket since the Apollo era, stands ready. Having undergone and passed numerous tests, the time has come to complete the journey. With hardware originating from every state in the nation and from partners around the world, Artemis 1 will be the first flight test of each of these components now assembled together. Two solid rocket boosters will provide more than 75% of the thrust necessary to leave Earth. Each booster stands 17 stories tall, a full segment more powerful than the SRBs of Shuttle. Together, these boosters are capable of 7.2 million pounds of thrust and will burn for the first 2 minutes of flight. The core stage, at 212 feet, is the tallest rocket stage NASA has ever built. With the rocket's flight computer secured inside, the core stage is designed to hold 2.3 million pounds of fuel. The 196,000 gallons of liquid oxygen and the 537,000 gallons of liquid hydrogen will combine to provide 8.5 minutes of propellant to the 4 massive RS-25 engines mounted below. As proven workhorses of the shuttle fleet, each RS-25 engine has a legacy all its own. Together, these 4 engines provide 2 million pounds of thrust, and with the SRBs, are capable of pushing Orion to a speed of 17,000 miles per hour. The interim cryogenic propulsion stage is a 45-foot tall upper stage that offers Orion nearly 25,000 pounds of thrust. Performing 2 separate burns, the ICPS will first raise Orion's orbit and then, later, propel it out on a trajectory to the Moon. The ICPS is powered by a single RL-10 engine that will perform these 2 burns. This storied engine has propelled robotic missions to every planet in the solar system, including Voyager 1 and Voyager 2, the first space probes to reach interstellar space. Orion's service module, provided by the European Space Agency, is the powerhouse that fuels and propels Orion in space. It stores the spacecraft's propulsion, thermal control, electrical power, and critical life support systems, such as water, oxygen, and nitrogen. Orion's crew module is the pressurized segment of the spacecraft, where future crews will live and work on journeys to the moon. Capable of accommodating 4 crew members for up to 21 days, this capsule includes state-of-the-art avionics, innovative crew systems, and the largest heat shield of its kind for entry back into the Earth's atmosphere. Positioned at the top of Orion is the Launch Abort System, designed to pull the crew to safety in the event of an emergency, on the pad or during launch. 3 solid rocket motors can activate in milliseconds, accelerating from 0 to 500 miles per hour in 2 seconds to propel Orion and crew safely away from the rocket. Now fully assembled, Artemis 1 stands at 322 feet. Artemis is no longer a series of separate parts and programs. United together, this is the first of Artemis's arrows, capable of ushering in the next chapter of human lunar exploration. Only together, this mighty system represents all that is possible, all that we are capable of when united around a stunning vision, with each component playing its part in a grander effort. We, the people of NASA and our partners, we, the people of the Artemis generation, all around this beautiful world, will bear witness to what we are capable of. Together, we are going back to the moon.
SpaceX have launched a new moon probe for South Korea. The flight was launched aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida. The spacecraft, named Denori, Korean for Enjoy the Moon, is on a low-energy ballistic capture flight path to the moon, which requires no delta-V and allows the probe to quite literally fall towards the moon. It should arrive in lunar orbit insertion in December. The solar-powered spacecraft will orbit 100 kilometers above the lunar surface for a year, gathering geological data. The probe is carrying 6 scientific instruments, including a camera for NASA that'll search for water ice in the permanently shadowed crater floors that never see sunlight. Other instruments include a lunar terrain imager, a wide-angle polarimetric camera, a magnetometer, a gamma-ray spectrometer, and what they're calling a delay-tolerant networking project. Basically, it's designed to undertake a range of communications experiments. The $180 million mission is South Korea's first to the moon. Back in June, South Korea successfully launched a package of satellites into orbit using its own rocket for the first time. The country plans on landing a probe on the lunar surface in 2030. The mission joins spacecraft from the United States, China, and India currently operating on or around the moon. Russia has launched an Iranian spy satellite into orbit, further cementing a new axis of evil between the two despotic nations. The Islamic Republic's maintained close ties with Moscow and has refrained from any criticism of the Russian invasion of Ukraine. The 600-kilogram Kayam satellite was launched aboard a Soyuz 21B rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The Washington Post quoted Western intelligence officials as saying that Russia plans to use the satellite for several months to assist in its war efforts against Ukraine before allowing Tehran to take control. However, Tehran insists the Islamic Republic would control the satellite from day one due to the satellite's encrypted algorithms. The growing international isolation of Russia under the weight of Western sanctions over Ukraine has seen the Kremlin seek closer ties with nations like China, Iran, and North Korea. Ironically, Iran is currently negotiating with world powers, including Moscow, over its growing secret nuclear weapons program. Tehran insists its nuclear program is for peaceful power generation only. However, it continues, either through its own efforts or espionage, to develop technologies which can only be used for nuclear weapons. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new model developed by Caltech and NASA's Jet Propulsion Laboratory in Pasadena, California, suggests that Antarctica's ice shelves may be melting at an accelerated rate up to 40% faster than previously thought, and that in turn will contribute to far more rapid sea level rise. The new computer simulations focused on just the West Antarctic Peninsula. The findings, reported in the journal Science Advances, accounts for an often overlooked narrow ocean current along the Antarctic coast, and it simulates how rapidly flowing fresh water melted from the ice shelves can trap dense warm ocean water at the base of the ice, causing it to warm and melt even more. Ice shelves are outcrops of the Antarctic ice sheet, found where the ice juts out from the land and floats on top of the ocean. The shells, which reach several hundred meters thick, act as a protective buffer from the mainland ice, keeping the entire ice sheet from flowing out into the ocean, which would dramatically raise global sea levels. However, the warming atmosphere in oceans caused by climate change are increasing the speed at which these ice shelves are melting, threatening their ability to hold back the flow of the ice sheet into the ocean. Well, it's been talked about for decades, and they even began making their first tentative steps back in the 1990s and early 2000s. Now, scientists at the University of Melbourne are finally about to try to bring the Tasmanian tiger, or thylacine, back from extinction. The dog-sized marsupial carnivores were slaughtered in their thousands by politicians and farmers throughout the 1800s and early 1900s who wrongly blamed them for killing sheep. The last thylacine died alone in a small cage in a Hobart Zoo in 1936. Now, Texas-based company Colossal Biosciences has announced plans to try and resurrect the thylacine. The company's already working on efforts to clone a woolly mammoth, using a combination of mammoth DNA and that from its closest living relative, the Asian elephant. They're going to try and create an embryo carrying the combined DNA, which could then gestate either in a surrogate African elephant or in an artificial uterus. Now, the resulting creature wouldn't technically be a mammoth. They're calling it an Arctic elephant, with small ears, shaggy hair, a domed forehead, and curved tusks. Earlier thylacine cloning attempts using museum specimen DNA failed, and interest in the project gradually faded away until now. The good news is scientists have some 96% of the thylacine's genome already sequenced, but that final 4% is proving to be the hardest. To find the remaining DNA, scientists are turning to one of the thylacine's closest living relatives, the fat-tailed dunnart, a relatively abundant mouse-sized marsupial. However, many scientists question whether it could ever work. After all, there are some 40 million years of evolutionary history separating the two species. A new study shows that around 1 in 20 people who contract COVID-19 may end up with long-term damage to their sense of smell and taste. The findings, reported in the British Medical Journal, are based on a review of global long COVID research. The authors combined studies with a total of 3,700 patients to estimate how many people didn't recover their sense of smell or taste after losing it during a COVID-19 infection. While researchers note that the studies relied on participants assessing their own ability to taste and smell and don't factor in different variants, they say 5.6% of COVID-19 patients suffer long-term loss of smell and 4.4% suffer long-term loss of taste. So far, more than 6.5 million people have been killed by the COVID-19 coronavirus. However, the World Health Organization says the true death toll is likely to be over 15 million, with more than 600 million confirmed cases now globally. Well, a lot of people are looking at hydrogen as a potential long-term replacement for gasoline-powered cars. But there are many hurdles. Now, scientists have come up with a new design for hydrogen storage which could reduce one of those hurdles: solid-state hydrogen fuel cell charging times. Hydrogen's gaining a lot of attention as a way to store energy from renewables such as wind and solar. Compressed gas is the most common form of hydrogen storage, but it can also be stored in a liquid or solid state. Solid hydrogen storage, and in particular metal hydride, is attracting interest because it's safer, more compact, and more economical than compressed gas or liquid, and it can reversibly absorb and release hydrogen. The problem is metal hydride hydrogen energy storage has low thermal conductivity, which leads to slow charging and discharging times. Now, researchers at the University of Technology Sydney and the Queensland University of Technology have designed several internal heat exchangers for use with metal hydride hydrogen storage in order to test their different performances. These have included simple straight tubes, helical coils or spiral tubes, U-shaped tubes, and fins, all of which sped up heat removal from solid fuel cells, resulting in faster charging times. The findings, published in the journal Scientific Reports, show that using semi-cylindrical coils worked best of all, reducing hydrogen charging times by 59% compared to helical coil heat exchangers. 3 new studies have examined the effects of fasting diets on the immune system, and they've found the lengths and types of fasting had different and sometimes opposite effects. The findings, reported in the journal Cell, show that a diet involving eating one day and consuming only water the next resulted in the number of inflammation-causing monocyte cells in the bloodstream to drop when fasting. The second diet, which simply cut calorie consumption in half, found increased protection against infections or tumours. While the third study looked at the effects on the gut of multiple rounds of water-only fasting, finding that it weakened immune response. Owners of iPhones, Macs and iPads have been urged to update their devices immediately following the discovery of a major security issue. The 3 Apple operating system updates, iPad and iOS 15.61 and macOS 12.51, fix a pair of major bugs that allow hackers to take over your devices and run code without permission. Apple says these vulnerabilities may be actively exploited, so any device not updated could be attacked. And now with the rest of the technology news, we're joined by Alex Zaharov-Reut from ITWire.com, who's reviewing the new MacBook Air M2 and the latest internet security offerings from Norton.
Yeah, well, I purchased the MacBook Air M2. I got it with the 10 GPU core with 24 gigabytes of RAM and a 1 terabyte SSD. The performance has been great. I mean, the clock speed on the M2 is higher.
What does clock speed mean?
Well, clock speed is the speed at which the chip is able to perform its operations, and there's a higher clock speed on the M2 than the M1.
You can change that clock speed.
On PCs, many PCs allow you to change the voltage of the chip and change the clock speed and change how it operates, and there are actually limits as to where you can do it. Overclocking is something that used to be frowned upon. Now it's a lot more common, and there are limits you can do it to within legal limits, and then you can go over, and some people cool their systems with, I think it's nitrogen, or to totally cool it down to really very, very cold levels, whether it's water cooling or using the nitrous oxide super cooling capabilities that if you put your hands into it, it would instantly freeze and you would lose your fingers. But people do use that to cool their CPUs down to get them to overclock to crazy speeds. Now, on a Mac, there's no official way to do that. There was a scandal, supposedly manufactured, that the MacBook Air M2, which has a passive cooling system, it has no fan, like the MacBook Air M1, unlike the MacBook Pros and the iMacs that have a fan inside, which allows it to have high performance for longer before needing to cool down. The M2 also throttles itself when it gets too hot, and apparently this was a scandal because this happens, but newsflash, the M1 thermally throttled itself when it got too hot as well, and it cools down very quickly, and some people were able to put a bit of thermal paste and an extra pad on top of the chip, which was able to keep it cooler for longer, but that dangerously directs the heat to the bottom of the case in a way that Apple never intended. Also, another scandal was that the base model of the MacBook Air has a 256 gig chip inside for the 256 gig of storage. And in the MacBook Air M1, there was 2 128 gig chips. And when you have 2 chips, you can write to both chips faster than one single chip. But I bought the 1 terabyte model, which comes with 2 512 gig chips. And I've noticed that it's faster. The keyboard is nicer to type on. The screen is a bit bigger. It's noticeably a little bit brighter. It's 25% brighter, 100 extra nits. So the MacBook Air M2 is a great machine, and a lot of the supposed scandal is just a storm in a teacup.
And while I've got you, let's talk about what Norton's are up to.
Yeah, so Norton has released Norton 360 Advanced. This is a new version that includes a whole stack of identity theft protection, as well as the usual dark web monitoring and spyware spyware, ransomware, malware, and antivirus protection, things like turning off your webcam if you want that to be the case on PCs, and automatically updating on PCs various types of software like Zoom or browsers, etc. But the new version has, in addition to dark web monitoring, where it tells you whether your password's been leaked online, it's got 58,000 Australian dollars of insurance, so that because no company can prevent all identity theft, even though you are obviously engaging Norton to do that. The bad guys are very smart, and if they do manage to get through, there's this insurance that can be paid to you to help recover from loans taken out in your name, or if you've had to get new credit cards or other ID. So that is the first time that internet security has gone to this extra level of actually not only just doing a form of identity theft protection, which is something that Norton has been doing ever since it merged with LifeLock in the US, but now offering this insurance as well. They put a couple of reports out recently on family and home, identifying what are the best ways to keep children safe, and also how phishing for new bait on social media is one of the newest reports that talks about how just in the last quarter alone, which is April to June 2022, Norton thwarted over 900 million threats, or about 10 million threats per day globally. There were 22.6 million phishing attempts globally. There was just under 1 million in Australia. There were 103 million file threats globally, with 1.5 million of those in Australia. And also in Australia, over 41,000 tech support threats were blocked. This is where somebody is trying to pretend that they're from Microsoft or Google or Amazon or somebody else, and they on your computer screen you get these messages. I've had people ringing me actually, and the sirens blaring in the background, and it's a web page that's trying to tell you that your computer is infected and you need to call this number now. And I wanted to know how to get rid of it, and I just said push Control F on the keyboard, which is the command to close down that window, and it went away. But of course, if you weren't aware that this was a scam, you might think it's real. And the bad guys out there are really trying every trick in the book. People might remember the flu bot messages coming into their inboxes on their phones about a missed parcel or a COVID certificate, missed doctor's appointment. Some of the latest ones, I got one the other day saying, "You've won," and there was a tinyurl.com/link, and it didn't say what I'd won, it just says click here to find out what it is. And in the word you've, there's a zero instead of an O, and there's a capital U instead of a lowercase u, which is sort of visually strange. But the other one is on WhatsApp, where people get this message saying, "Hi mum, hi dad," and then they proceed to spin a story that their mobile phone's been damaged or lost, they had to get a new number, they can't talk to you because their microphone is broken on their existing phone, for which they had to get the new SIM, and they've got some emergency that they need several $1,000s for straight away, an afterpay payment or something that requires instant action. And when the parents sort of say, "Well, who is this? Is this Tim or Sarah?" "Oh, it's Sarah." A lot of the people are giving away information that the scammers then use to basically fool you into thinking that you're talking to their real child. And of course, what parent doesn't want to help their child out? So a lot of Australians have been caught out by this, and this is the same with when there's Valentine's Day scams, there are shopping scams around the time of sales. People are trying to sell things at cheap prices, or they claim they're on a military base somewhere and they will send you the money, but they can't come over to check it in person, and then the money is transferred, but somehow it never gets.
That the Nigerian prince has been contacting me is false.
Well, they're trying to become a lot more sophisticated, these scammers, but they really are trying every trick to try and get you to drop your guard, because as always, you are the weakest link, and they're trying to socially engineer you. I mean, yes, they're trying to break into your computer or hack into your phone, but if they can get you to voluntarily believe that they are your child, or voluntarily send them money to this account because, something's wrong with my bank account, I need you to pay this afterpay for me, it's something that is catching a lot of people unawares. And although the ACCC
to have fun with them,
there are some people who spend a lot of time trying to waste the time of scammers.
Yeah, that's what I do.
The problem is the scammers have your phone number or email address. They have some of your details, so they can then sign you up to spam lists or get some of their other friends in the same call center to call you and harass you. So if they really get annoyed, it is possible for them to retaliate, as it were. Now, there are certainly experts at this who will actually figure out how to hack in to the call center, and there are videos on the internet where people do this, and they actually show the hackers their own vision from their own webcam, and you can see they're totally surprised by seeing their own face on the screen.
I want that stuff.
But you need to be a real security expert to be able to do that. If you're not a security pro, then it's probably better to just hang up the phone. I also remember hearing stories and reading stories about how people pretended to be befuddled elderly people, and they look as though the person's on their computer watching what they're doing and going to transfer the money, and oops, I've transferred it somewhere else by accident, and the other person's going, no, please just do this or do that. They think they've got a live one. They think they're going to make several $1,000s, and they're just being taken down a path where their time has definitely been wasted. So look, if you want to go down that path, by all means, people have a lot of fun screwing with the scammers.
That's Alex Zaharov-Reutt from ITWire.com. One of the big problems with reporting on psychological studies and surveys are the small sample sizes. Political surveys of less than 2,000 voters are generally considered too small to provide an accurate representation of public opinion. And Phase 3 medical trials usually need at least 3,000 participants in order to gain a fair and accurate representation of the likely effects of any new drugs. In recent years, we've been seeing more and more surveys covering psychological issues. Trouble is, they're almost always contradictory. The problem is the small sample sizes they have to work with. See, it's rare for two patients to have exactly the same psychological conditions. In reality, they're all on a spectrum with a myriad of other influences. People are individuals like that. And this makes generally applicable scientific studies very difficult. Tim Mendham from Australian Skeptics says there are just too many variables.
Behavioural psychiatrists are basically people who try and treat people through behaviour techniques, which is therapy as much as anything else. Controlling your symptoms, trying to do things that will sort of alleviate any negative impacts, as opposed to medical psychiatrists who use medication. Okay, so there's those people who use therapy and those people who use medication. And what's happening is that a lot of psychiatry over the years has been criticised as being a soft science with no real hard data to substantiate any particular theories, and obviously you get a whole lot of different
psychology as well, can't you?
Well, that's right. Yeah, it is a soft, because you're dealing with human beings and mental issues, so it is a very subjective area. So it's understandably softer than say physics or chemistry, but the feeling is amongst a lot of psychiatrists and psychologists is they want to get more scientific. They want to get more into the hard science. So they're looking for data, they're looking for scientific methods, they're looking for practicalities, treatments and things that they can quantify.
First thing they've got to do is stop doing surveys and studies using just 5 or less people. You've got to start having big groups of 2,000 or more. That's how you do that.
That's the hard thing to do, because you've got to find 1,000 or more people who have the same sort of condition. And it has to be the same condition, not little variations. And that's the trouble with psychiatry and any mental condition, actually, that there are subtle variations from person to person. Everyone's on a spectrum, and they don't necessarily all sit on the one spot. So having 1,000 people who sit exactly on the one spot, so you can compare them, is very hard in mental health issues.
Yeah,
and
because with autism, it's not a single disease; it's a spectrum.
It's also one of the problems with depression, of course, very much so. And what some people are criticising psychiatry for is it rushes to this prognosis of depression, and therefore wants to treat depression medically with pharmaceuticals and things like that. Whereas some people are saying, okay, there is medical psychiatry, there is treatment with pharmaceuticals, pills, drugs, whatever, but there's also those psychiatrists who want to treat with therapy who feel a bit left out from the scientific paradigm, if you like, or the aura of being scientists, and they want to move into the medicalisation, as they call it, of behavioural psychiatry. So it's an interesting area. One particular article by a noted psychiatric academic in psychiatry was saying there's a major issues with behavioural psychiatrists trying to move into a medical area, because he said the data is often rubbish. As you were saying, small sample size is one of the issues, giving clues all the way through. They said one particular example was a treatment for PTSD amongst ex-military, and the treatment included MDMA, which is ecstasy pills, psychedelic sort of, if you like, effect of those pills.
I've heard of them.
Yeah. And they said that the trouble is the sample they got for that, and you talk about samples, a lot of people would have been turned off and said, I don't want to take drugs for this trial thing, I'm not going to take drugs. So the people they got were those who were willing to take drugs for a start, and then they told them that you're going to be taking either the real thing or a placebo, and then these are the symptoms you should be feeling. So the people who didn't get those feelings reckoned they got placebos, and therefore they continued with that attitude, with those who did get symptoms assumed they got the real thing and continued down that track. And the numbers of people involved, I think this one was 90 or something like that, is small, and the methodology used is dodgy, or at least weak. So they're suggesting that psychiatrists and the psychiatric profession should be very careful about moving into the medicalised area, into the area of hard data, because it just doesn't work, or at least it hasn't been shown to work, because the data is just extremely rubbery. And so therefore it's an interesting situation that psychiatrists are still stuck in that soft science area, and they're trying to get out.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.